Namaste students, welcome to our today's video, the solid state part 6 on locating tetrahedral and octahedral voids of chapter 1 from class 12 chemistry part 1. Now first we will discuss locating tetrahedral voids in cubic closed pack or face centered lattice. We know that closed pack structures have both the tetrahedral voids and octahedral voids. As we cannot locate octahedral voids or tetrahedral voids in BCC or body-centered unit cell, let us consider a cubic closed pack or face-centered lattice. Now see, what is tetrahedral voids? When a sphere from second layer is placed above three spheres of first layer, then a tetrahedral void is formed. Three spheres of first layer forms a triangular void. If we join the centers of three spheres, we will get a triangular shaped void. And if we place a sphere above this void or below this void, we will get tetrahedral voids. So four spheres surrounds the tetrahedral voids. Suppose these three are the center of the spheres of first layer. Fourth one is the center of the spheres of second layer, which is placed above the triangular shaped void of the first layer. And if we join all the four centers, we will get tetrahedral void. So this is the tetrahedral void. Three spheres are in the same plane and one sphere from second layer is placed above the triangular voids and it forms tetrahedral voids. If we take that n be the number of closed packed spheres in a crystal lattice, then total number of tetrahedral voids in a crystal lattice will be twice n. Let's see locations of tetrahedral voids in cubic closed pack or FCC lattice. In face centered unit cell, 6 particles are there in 6 faces and 8 particles or spheres are there at 8 corners of a unit cell. We will take 3 spheres in same plane. Now if we take 3 spheres from 3 faces in one plane and that corner one is above this 3 sphere, so it will form a tetrahedral void. Now for ionic crystal, the lattice sides are occupied by anions whose size is greater than that of cation, and cation take the void place, so that 4 spheres are surrounding the tetrahedral voids, which is located at the body diagonal of the unit cell. Now similarly, if we take another 3 sphere from 3 space, this one and that one, all 3 are in same plane and one sphere at corners which is above this 3 sphere, it will again form a tetrahedral voids whose center will be on the same body diagonal. So 2 tetrahedral void is formed at each body diagonal. Now in a unit cell, 4 numbers of body diagonals are there. So the number of tetrahedral voids per unit cell of cubic closed pack structure is 4 into 2 equal to 8. Now we'll see locating octahedral voids in face centered lattice. What is octahedral voids? As you know, if 3 spheres from second layer is placed over 3 spheres of first layer, then that octahedral void is formed. 3 spheres of first layer touched each other, and if we join the center of these 3 spheres, we get a triangle whose apex is upward. And again, if we join the centers of 3 spheres of second layer, we will get another triangle whose apex is downward. So the one triangular void of second layer is placed over the triangular void of first layer, it will form octahedral voids. So here you see that 3 spheres in the first layer and 3 spheres from the second layer placed over this one, and total 6 spheres surrounds the octahedral voids. Now octahedral void can be also shown by 6 spheres in this way. 4 spheres are in one plane and one will be above this fourth sphere and another will be the below of this fourth sphere. So total 6 spheres will be there. 4 sphere in the same plane and 2 sphere, one above the plane and another below the plane, and if we join all the corners of these 6 spheres, we get a tetrahedral voids. N with the number of close packed spheres in a crystal lattice, then number of octahedral voids generated is equal to n. Now we will see locations of octahedral voids in CCP or FCC lattice. In FCC lattice, 6 spheres are there at 6 faces. Now if we join the centers of all these 6 spheres with a line, then we will get an octahedral void at the center of the body. One octahedral void will be generated at the body centers of the cube. Now see, another octahedral voids will be generated at the center of edge. Now this center of edge is surrounded by 4 spheres, 2 at 2 corners and another 2 are from faces of 2 adjacent unit cell. So if we join these 4 spheres, we will get one square. Now if we take one sphere below this 4th sphere from the face and another sphere above this 4th sphere from the face of another unit cell above this one. So one octahedral void is generated at the center of each edges. Only 1/4 of each void belongs to a particular unit cell. Total number of edges in a unit cell is 12. Now in a octahedral voids, 12 edges are there. Each edge has one octahedral void and whose contribution is 1/4 to a particular unit cell. So total contributions from 12 edges is 12 into 1/4, and the number of octahedral voids is equal to 12 into 1/4 plus 1, that is 4. So in case of tetrahedral voids, if 4 number of constituent particle is there, total number of tetrahedral voids in a unit cell is 8. Then twice n number of tetrahedral void is formed. Here we know for a face centered unit cell, total number of constituent particle is 4 and the tetrahedral voids generated is equal to 8. So we can say if n number of constituent particles are there in a crystal lattice, then total number of tetrahedral voids formed is twice n. And it has been found that for a crystal lattice, if n number of constituent particles are there, then n number of octahedral void is formed. Here in case of face centered unit cell, 4 number of constituent particles was there, so 4 number of octahedral void is formed.